This is question number 21, and we are told the position vectors of A and B are OA is equals to 2, 4, and OB is equals to 12 minus 4. A point M on AB such that AM is equals to a half AB, and a point N is on OB such that the ratio of ON is to NB is equals to 1 is to 3. So part A of the question, find Roman number 1, AB, Roman number 2, NM, Roman number 3, magnitude of NM, correct to 1 decimal place, you get 2 marks. Part B of the question, we are told a translation vector maps A onto A prime, which is 5 minus 1. Find the coordinates of the image of B under this translation vector. Now, to be able to answer this question well, it is okay. I think it is good to have a sketch of what is being described here. You make a sketch so that you can be able to see what is happening. So I would say that is my line AB. So I say this is the origin. So I'll join the origin and AB, just a sketch. Don't worry about it. So this is the OB. So you can get this when you are given the vector OA, which we have here. We have OB, which we have here. Then we are told M is a point such that AM is a half. So it means that the point M divide AB into a half. That is the ratio. You can write it is 1 to 1. Then we are told N is a point on OB such that ON is to OB, NB is equals 1 to 3. So we can say OB has been divided into 4 parts. So one, that is where we have the N. So this is 1 and this is 3. Now we have the information that we need to be able to now answer our question. Now we come to Roman number 1. We are told to find AB. So to find AB in vectors, which you covered in Form 3, you are required to find an alternative route to move from A to B. And the alternative route is AO. And before that, you note that we are moving against the direction of the vector. So that will be minus OA, because we are moving against the direction of the vector. And then OB, that will be okay. So we can come here and say our AB is equals to, we have said it is AO plus OB. But for us to be able to express AO in terms of AB, we say that this is minus OA. The minus represent the negative direction, plus OB, which we can write as OB minus OA. Just writing that so that you can understand. But during the exam, of course, when you are used to solving this kind of question, you don't need to write all this. So we will say this is equals to, our OB is 12 and minus 4, and our OA is 2 and 4. So close the bracket there, is equals to, when you are subtracting, we subtract the corresponding elements. So it is 12 minus 2, that should give us 10. This is minus 4 minus 4, that will give us minus 8. And therefore, that is our vector AB. We come to NM. NM, we say it is, we can say it is a vector originating from N to M. So that is our NM. And therefore, to move from N to M, the shortest route is NB and MBM. So we say that NM is equals to, we say it is NB and we add to BM. So this is equals to You note that our NB is 3 out of the 4 parts of the OB. So we can say NB is 3 out of 4 of OB, which we already have been given up here. Then we say plus. You note that in parallel number 1 we had AB, so but we are moving against the direction of OB. So instead of okay, we can say it is and BM is half AB, so we can say it is a minus a half of AB. The minus, we put the minus to represent the direction. We are moving against the vector AB, which we have already gotten there. So we say this is 3 out of 4. What is our OB? We have been given here. It is 12 and minus 4. Now here it's plus and minus, so we have minus. I have AB. We already have AB in our part A, so it is 10 minus 8, which is equals to, now when you, I think I can use this part here, 3/4 of 12, it is 3/4 times 12, that will give us, that is 9, because 4 and 12 will cancel, we have 3, so 3 times 3 is 9. 3/4 of 4, 4 divided by minus 4, that's minus 1 times minus 1 times 3, that will give us minus 3. And then we have, now we have a half of 10 is 5, a half of minus 8 is minus 4. So this is equals to 9 minus 5, that will give you 4. Minus 3 minus minus 4. Minus and minus will be positive. So it will be minus 3 plus 4, which will give us 1. So that is a vector NM. I hope you have followed that. We come to part 3, Roman number 3. We are required to find the magnitude of NM. Now, magnitude, remember, when you are taught that if you are given A is equals to X and Y in column vector, the magnitude of A is equals to the square root of X plus, that is X squared plus Y squared. And now that we have NM, then here in part Roman number 2, this is our NM. So we say NM, the magnitude, is equals to the square root. We say it is 4 squared plus 1 squared, which is equals to the square root of, this is 4 squared is 16, 1 squared is 1, so that's the square root of 17. And using your calculator, you get the square root of 16, you get it is 4, getting 4.1. You get other decimals, but we are told to write in one decimal place. So that is a magnitude of AB, and that is 1 to 1 decimal place. Very important. So that's another, you get 2 marks for expressing that. So finally we go to part B. And part B, we are required to, a transition vector maps A onto A prime 5 minus 1. Find the coordinates of the image of B under the translation vector, that is under the same translation vector. A translation vector is when you move the position of a point or an object from one place to the other. And on the Cartesian plane, that is XY Cartesian plane, we say you move along the x-axis certain units, along the y-axis certain units. So we can say, we already got, we can say OA prime is equals to OA plus the translation vector, which we can use T to represent that. So if we find T, we will be able to get the coordinates of B. So this we can say OA, okay, already we have we can take T is equals to, we take OA to the other side, so it is OA prime, okay, minus OA, so that we get the translation vector. So this implies T is equals to We already have OA, or we can form OA using the coordinates 5 minus 1, and we already got the OA here, which is 2, 4. So it is 5 minus 2, that will give us 3. Then 1 minus minus 4, that will give us minus 5. Minus 5. So now we got the translation vector. This means that we will be able to get OB prime is equals to OB. Then we have OB plus the translation vector, which is T. We already have, this implies that OB prime is equals to, our OB is 12 and minus 4. Then we have plus the translation vector we have found, it is 3 minus 5. So it is 3 minus 5. Now this will be able to give us 12 plus 3, that is 15, minus 4 plus minus 5, that will give us minus 9. So that is our OB. This implies that we can get the coordinates of B, that is the coordinates of the image of B, which you call B prime, 15 and minus 9. So that's how you work out that. In terms of awarding of marks, here you get 2 marks for expressing that and getting the answer there. The same case applies here. You get expressing that and also getting the correct answer. Here you get a mark for that and a mark for the answer. Here you get 3 marks. So for getting the translation vector, expressing OB in terms of using the translation vector, and finally getting the coordinates. So you covered this in Form 3. That is vectors 2. And this is a very good question. But something to note is that when you are answering vector questions, make sure that the initial part of the questions, you get that part right. Note here, we were told we are supposed to get AB, which we got. You find AB, we have used it down here. So if you get the wrong place, then the wrong value, then you will not be able to get part B, and so on. So it is kind of related. So that's how you answer that question.